Hey, this is lesson 20, Ionic Bonds, home edition, because again I have this sick kid running around. Last time we looked at things like this. Sulfur has 6 valence electrons, that means it has 2 lonely ones, and each of those is going to try and grab a partner from somewhere. So now today we'll look at what it means when it finally gets its partner. We also said that's called an ion. It gets a charge. It now has 2 negative for a charge. So, note-wise for this, ionic bond is when you have a metal and a non-metal. And anytime you have bonds, it's because of electrons that get shared or traded or stolen, basically. So, with these, what we said in the last unit, or last lesson, metals give up electrons and become positive. Non-metals will take electrons and become negative. And kind of maybe we said it. The new idea with this is when you make your positive ion your cation and your negative ion, which is your anion, they are going to be held together by the attraction of the positive and the negative. So they don't have anything like just linking the two atoms. There's nothing holding them physically together, but they just have this kind of shared attraction toward each other because one's positive, the other one's negative. So, examples. Let's say you're bonding a metal and a non-metal. So, for a metal, it's something on the left side. So, let's look at sodium. And the non-metal, let's say that's oxygen. So, for sodium, it has 1 valence electron. For oxygen, it has 6. So on these, again, it's important to have something on all sides before you pair any up. And so we have 2 lonely electrons, so that means this one needs 2. Pretend that says needs 2. This needs 2 electrons. This one has 1 lonely electron, and it's going to give it up because it's the metal. So the way to draw these bonds is kind of what we'll look at now. So first off, just draw the valence electrons for each element, like we did there. The goal basically with this is if I give you 2 elements, can you tell me the formula? Alright, add arrows to show where the electrons go. So, is sodium going to gain 7 electrons somehow that are drawing to it, or is it going to give up 1? Well, with sodium, it's going to be easier to give up 1. So it sends its electron from here to something that will take it, which is now that oxygen, because the oxygen wants 2. The problem is, if oxygen wants 2, that sodium doesn't make the oxygen happy enough. So we need to add more of whichever element until all of the lonely dots are taken care of. So we need another sodium. And that sodium is going to add its electron to the oxygen. So now oxygen has a total of 8. Each sodium has, underneath that shell, there's another full shell. So they would each have 8. The total valence electrons are 6 for oxygen, plus 1 for the sodium, plus another 1 for the sodium. So it's a total of 8 valence electrons altogether. There's kind of a pattern with these. Whatever that number is, it's always going to be a multiple of 8. So we'll see some other examples of those later. So once you have that, for the pictures, like what I'm looking for when I'm grading pictures, is that then you add charges and check to see if they add up to 0. So sodium gave up 1 electron, so it becomes a positive 1. The oxygen gained 2 electrons, so it's a 2 negative. And so 1 plus 1 plus negative 2 equals 0. So that's how you can tell one way that you did it right. So what if instead of sodium and oxygen, what if we went with, let's have you do, so you can pause it once I give it to you. See if you can do calcium and chlorine. That would be calcium chloride. So see if you can do those. So the pictures of them, calcium has 2 valence, chlorine has 7, so each, I guess this one has 1 lonely dot, calcium has 2. So calcium, because it's a metal, is going to give up its electron to chlorine. That makes that chlorine happy. Yay! This guy right here, still sad. So it needs to give up its electron to something. So it's going to give it up to, oh, I don't know, let's say another chlorine. So with the infinite powers of Smartboard, I can add another chlorine. Yay! So now that chlorine has 7 plus calciums to give it 8. So in this case, you have 2 valence on calcium, 7 on chlorine, 7 on chlorine, so altogether that is 16. So like I said, it's a multiple of 8. So then last thing is do the charges. Calcium gave up 2 electrons, so it's a 2 positive. Each chlorine gained 1, so it's 1 negative, 1 negative. So 2 negative, 2 positive equals out to 0. That means you did it right. So the formula on this would just be calcium and then 2 Cl's. That's how you write the formula. For the sodium oxide, we had 2 sodiums with 1 oxygen, so it's Na2O. Alright, those are easy, simpler ones. And so those are easier to predict the formula, because if eventually you won't have to draw the pictures, and it becomes a big pain if you do. If I just tell you, hey, calcium and chlorine are going to combine, tell me what that makes, you don't want to have to draw the pictures. Although if you do, that's okay if you need to get it right. So predicting the formula can be done kind of simple. So just write the symbols with their charges. So we'll do the calcium chloride. So just write them like you would for the formula, leave a little bit of room here in case you have to put numbers. So on the periodic table, calcium, we know from the past unit, that's in the second column, so it's going to be a positive 2. Chlorine's going to be a 1 negative. So right here, just calcium, 2 positive, chlorine's going to be a 1 negative. So that's kind of step 1 on predicting the formulas. A way that almost always works is once you have that, you take the charge for each one and you cross it down. You take the charge and you cross it down. And so what you get is calcium, and if it's a 1, you don't have to write a 1, because if there wasn't really one of them, then we wouldn't write it in the first place. So if that's the case, just write calcium. And the chlorine, you take the charge of calcium, bring it down here, I would need 2 of those. So in total, that gives me a 2 positive, because that's what calcium already was, and the chlorine would be negative times 2, because I have 2 of these negative ones, and so that would equal 2 negatives. So again, 2 positive, 2 negative, cancels out. Alright, so predict the formula for if you have rubidium and nitrogen. So Rb and N. Ready to go. Alright, so for these, rubidium has a 1 positive, nitrogen has a 3 negative, because it would need 1, 2, 3 electrons to get to that full outer shell. So I must need 3, just take that number here, put it down there. I need 3 positive 1s. I need 1 negative 3 to make it work. So 3 positive, 3 negative, yay! And this is really helpful for ones like magnesium plus nitrogen. Okay, so see if you can figure out magnesium and nitrogen. We've got magnesium 2 positive, nitrogen 3 negative. So it's hard to find a number those both go into. 2 and 3 both go into 6, though. So if you took that 2, put it down there, take the 3, put it down there, that gives you a 3 times 2 positive. That equals a 6 positive. This is a 2 times 3 negative. That would be a 6 negative. Hey, that equals 0. So the number cross always works except for a couple of exceptions. So the exceptions would be something like magnesium and oxygen. So in order to get these to equal 0, I do not need to number cross and put a 2 here and a 2 here. Yes? One moment, please. All right. He's suitably entertained now. So you don't need 2 of each one of these. They already cancel out. So anytime they already cancel out, don't do the number cross. The other exception would be something like, and this is rare that you even go into this column, but carbon. Carbon would be for positive or negative, like this whole row. It depends on whether they go to the right or left. Carbon, though, could be for negative. So if you're looking at that, you wouldn't want 4 and 2 down here because it's kind of like fractions. You want the most reduced fraction. So if you had the fraction of 2/4, you would reduce that down to a half. So if things go into each other like that, you should realize I need 2 magnesium and 1 carbon. So that would be 2 times 2 equals 4 positive, 1 times 4 equals 4 negative in order to balance out. So those are the exceptions. What I like to do that always works even better than number cross sometimes, except for the 2 3s. Those are tough. Hi. What I do is use your fingers. So magnesium needs 2. Oxygen, or magnesium will give up 2. Oxygen will take 2. So how many oxygens for the magnesium? Just 1 of each. Sodium gives up 1. Oxygen will take 2. So how many sodium? 1 sodium takes care of 1 lonely dot. You need a second sodium for the second lonely dot. So using your fingers is really hard to screw it up. It's just if you get the 2 and 3, do this and that, but it's really tough. But on most of them, use your fingers, see if it works out. One last thing with this, and that is to look at the naming, which I've said the names a couple times of things. So we had sodium and oxygen, Na2O. The naming is just metal, which is always written first, non-metal, and you change the N to IDE. So that would be sodium oxide. We had calcium and chlorine. So calcium and chlorine would be calcium chloride. Basically, this whole row, you change the N in it to a D. So fluorine would be fluoride, chlorine would be chloride, bromine would be bromide, iodine would be iodide, oxygen is oxide, nitrogen is nitride, phosphorus is phosphide. So it's basically you make it 2 syllables and you change it into IDE. That's about it. So that's ionic bonds, which we'll play with extensively in the future.